Hello, David Snopek here from Snopek Games, and this is part 4 in a video course about using the Git version control system with a game project that uses the Godot game engine. So, quick review, what did we learn in the last part? We had a small discussion about how big or small to make commits so that they are most useful when looking through or traveling through your Git history. We talked a little bit about dealing with commit IDs. We learned how to see the differences between specific commits using these Git command lines and also in the Git GUI. Returning to a specific version, wiping out the changes since the last commit, and reverting a commit. So a whole bunch of things about looking at or going through the history of your Git repository, both on the Git command line and the Git GUI. So what are we going to learn in this part? Well, we're going to talk a little bit about why we're using GitLab versus other alternatives such as GitHub, which is quite a bit more popular. We're going to go through the process of creating an SSH key and adding it to GitLab. We're going to be pushing and pulling your local repository to and from GitLab, and we're going to be poking around your project just a little bit on GitLab. So, why use GitLabcom as opposed to Bitbucket or the much more popular GitHub? Well, first of all, it's at least as good as GitHub, I will say that. There's some things that I actually like better about GitLab than GitHub, and I'm sure if you're used to using GitHub, switching to another tool, you will probably find things that you prefer about GitHub that you don't really like about GitLab. But like in all of the most important fundamental ways, the biggest pieces of functionality, the biggest features, they're essentially feature equivalent. So the main big difference between them is that GitLab is open source and GitHub is proprietary. And if you use the Godot game engine, which is also open source, you probably value open source for some reason in some way. For me personally, any opportunity that I have to use an open source tool rather than a proprietary tool, I will use the open source tool. And in this case, because they're so closely feature equivalent, I really don't see a compelling reason to use a proprietary tool. I mean, I will, of course, use proprietary tools when I have to, like if that's the only option, or for work where I just don't have any other choice. But when given the choice, I'd prefer to use something open source, and I hope that you feel similarly. Oh, and because it's open source, GitLab can actually be self-hosted if you want to. I wouldn't necessarily recommend it. It's a complex piece of software, and you're here to develop games, not maintain a GitLab instance. But like if you had a game studio or like a game collective or some sort of organization and you wanted to have your own private instance of GitLab, not GitLabcom, but your own self-hosted thing, you totally can, which is not something you can do with GitHub. Because it's proprietary, the only way to access it, the only way to use it is to pay them something. I mean, like they have some enterprise thing, you can pay them a whole bunch of money and they'll make like a private instance for you, but you don't own it or control it, they still do. And GitLab CI. GitLab CI is really great. And in the next part, we're going to be doing a whole bunch of cool stuff with GitLab CI. Until recently, this was actually a big feature that GitLab had that GitHub didn't. GitHub recently added its own built-in CI tool. There were always lots of tools you could use with GitHub to do CI, like Travis CI or Circle CI, but now they have their own thing. I haven't used it. I really can't say how good or bad it is, but GitLab's GitLab CI is really fantastic, and it's possible to self-host just that piece of GitLab, just the GitLab CI piece. So you can use GitLabcom and have all of your repos stored there, but then you can run your own GitLab CI server where all of your builds will run, so that you can have full control over your CI server or configure it to do things that the default configuration doesn't do, or if you're doing so many builds you are exceeding the free build minutes that you get on GitLab, you can do that. Anyway, for all those reasons, this tutorial series is going to focus on using GitLab. So let's get started. I'm going to switch over to my Windows VM here. And let me minimize that window. The first step is that we're going to create our SSH key and then add it to our account on GitLab.com. So to do that, I'm going to right click and go to git bash here. We're actually just going to do the SSH key creation process on the command line. Usually we do everything on the command line and in the GUI, but this is something that we only need to do once. You basically need to do it once per machine that you want to do development on and connect to your remote GitLab project. So we're just going to do it on the command line. It's a really simple thing to do. Just one command. It's ssh-key gen, G-E-N. If you're doing this on Windows, you have to do .exe. If this is on Linux or Mac, you just do that without the .exe, but otherwise the command is the same. And then we do space -t space RSA space -b space 4096. So like always, all of the commands that we're running are available in the cheat sheet document, which is linked down in the description below this video. So you don't have to worry about typing this exactly as I am. You can just go to that document and copy and paste it if you like. In any case, really quickly about what this command is doing, the -t is the type of SSH key. We're generating an RSA key. There's a couple of options. And the -b is the number of bits in the key. We're generating a 4096-bit key. These two values, RSA with this many bits, is a reasonably secure default for right now, for this moment in the year 2020. In a bunch of years from now, there may be different settings that are considered secure best practices. For now, this is fine. This should last you the next couple of years. So we've typed this. Let's press enter. And it asks us, enter file in which to save the key, and it gives this default. This default is fine. That's where Git's actually going to go looking for the key. So we just hit enter to accept the default. And then it asks you to enter a passphrase. So entering a passphrase is optional. You can just make it empty, and then there will be no passphrase. Whether or not you use a passphrase, I think is up to you and how secure your computer is, and how secure your use of the computer is, and how much risk you want to take. So basically, setting a passphrase will encrypt your private key file, and then you have to enter the passphrase every time you want to like git pull or push in order for Git to access that key. If you are not using hard disk encryption, if your hard disk is unencrypted, I highly recommend setting a passphrase here. Otherwise, anyone with physical access to your computer could potentially steal your SSH key and then impersonate you and wreck all your projects. But if instead your hard disk is encrypted, you use your computer very securely, for example, you're the only person who has access to it, and you don't run untrusted programs, and you have an antivirus and all that normal stuff, then you could decide not to have a passphrase, and it's probably fine, right? So for the purpose of this tutorial, I'm not going to set a passphrase, largely because I don't want to have you guys watch me enter a passphrase wrong 3 times every time we run a git command. So I'm just going to hit enter here. It's going to ask me to enter the same passphrase again. Since we did a blank one, we'll just press enter again, and it generates the key. This is where it's put the private key, and this is where it's put the public key. Even though we're on Windows, it's using these kind of like Unix style paths. So this /c means the C drive, and then it's using forward slashes instead of backslashes to separate the paths. So let's go find where these files actually are. That was in C, users david.ssh, and then those files. So let me close this. I'm going to go to C, users david.ssh, and here's the 2 files. So this first file, the IDRSA, that is the private key. That's the file you need to keep secure on this machine. And then the idrsa.pub, that is the public key, which you can expose publicly and in fact need to. You need to give that this key to GitLab so that it can identify you when you are trying to run git push and pull commands, and to encrypt the data that's being transferred between GitLab and your machine. So let's actually edit this file. I'm going to right click it and go to edit with Notepad++. And this big string of characters is actually your SSH public key. So I'm going to copy that. And then I'm going to switch over to GitLab.com. I'm already logged in. I'm basically going to start assuming you've already created an account on GitLab.com. If you haven't yet, pause the video and go create an account. It's really simple. It's like creating the account for anything. So just go over to GitLab.com, click register in the upper right-hand corner, fill in, the name, username, email, password, all that stuff, and follow the instructions. And once you've done that, join us back here to continue. So once you're logged in, click on your little user picture up in the upper right-hand corner, go down to settings, and then in the left sidebar there is SSH keys, click that. And then in this big box at the top, this is where we type, paste our SSH key. I couldn't imagine actually typing all of that. And it'll automatically inject a title down here. This is probably fine, but if you want to change that to something that will help you recognize which computer this is, which machine this SSH key is for, you can change that title to something else. Also, generally, do not copy your SSH key from one machine to another machine. If you have two machines that you want to do development on, it's security best practice to create a different SSH key on each machine. And that's so that if one of those machines gets compromised, you can just go in and remove that particular SSH key, rather than if you're sharing the same SSH key for everything. It's a much bigger hassle to go clean that up. And you can add as many SSH keys here as you want. So let me just click Add Key. All right, the SSH key is added, and now we need to create a new project on GitLab. So we're going to click the plus button up here in the toolbar, go over to New Project, select Create Blank Project, and enter a project name. We're going to call it Git Test 1, same as we've named the local project. And this part here relates to what the project URL is going to become. Go make sure this project slug is something that you want to be in the project URL. Maybe clean it up, since this is the URL you're going to be passing to all of your teammates and visiting all the time. And then the only other important thing here is the visibility level. You can create a private project or a public project. And like we discussed back in, I think it was the second episode, the email that you give to Git is going to be put in all of the commits that you make. And so if you create a public project, just know that that email that you told to Git will be included in all of those commits and then publicly exposed to the internet. So if you don't want your email to be known for some reason, or you don't want spammers to get a hold of it, either put in a different email address configured with Git, or make sure that you only create private projects, because then those commits will only be shared with the people that you invite to the project. So for the purposes of this tutorial, I'm just going to make a private project, click Create Project. And now we have an empty project. So since the repository for this project is empty, GitLab will give us these suggested Git commands that we can run, including here's the commands we did for the global Git setup way back in episode 2 of this series. Instructions for if you're creating a new repository with no existing files, if you have existing files but that aren't in a repository, or if you're going to push an existing Git repository. And it's this last one that's the closest to what we're actually doing. However, they include a bunch of extra commands that we're not going to be doing just because they kind of wanted to cover all possible cases. We only really want to run this command, and then a different sort of variation on this git push command. So we are going to copy and paste this URL here, which is the SSH URL for this particular project on GitLab.com. We're going to copy that. I'm going to go back to our project here, the same project we've been working on through the rest of the videos in this tutorial. I'm going to right click and go to Git Bash here. And we're going to tell our local repository about this remote project by running git space remote space add space origin, origin space this URL that we copied, and hit enter. So what this did was it told Git to add a remote named origin that is at this particular URL. And now we're going to run a command to actually push the master branch of our repository to that remote. So that's git space push space -u space origin space master. So that's saying we're going to push the master branch to the origin remote, and this -u is telling Git to set the origin remote as the upstream for this particular branch. And what that allows us to do is in subsequent commands, we can just say git push and git pull, and it will know which remote to push and pull from without us having to always specify it. So let's hit enter. It asks us if we want to accept the authenticity of this host. We will say yes. And now we can see that it is pushing the content of our repository to GitLab.com, and it has made the master branch to track the remote branch from origin. So that's the upstream thing I was talking about. So now that we've done that once with this -u, we can run git push without any arguments, and it will push the current branch, which is master, to the origin remote because it knows that those two are linked. So if we go to the page on GitLab.com again and refresh the page, we will now see a whole bunch of files from our repository here. And right in GitLab, you can click on any of those files, see their contents. This is actually pretty useful when working on a team. You can click a particular line and then copy and paste this URL and send it to your teammate and say, hey, go look at line 6 in the main.gd file. We also are able to see all of our commits here. So over on the left-hand side under repository, there is commits. And this is a list of all of the commits in our repo. And if we click one of them, we can see the diff associated with that commit. So this is pretty useful for collaborating with the team or just browsing through your project if you're not at your computer or something. There's a whole bunch of other interesting things in GitLab. In the later part where we're going to be talking about branching and merging, we'll talk a little bit more about issues and merge requests. And in the next part, we're going to talk more about CI and GitLab CI. And there's a whole bunch of other cool things in here, which we won't have time to go over in this tutorial, but it's cool stuff. You should poke around as well and see what's there. So if your teammate wants to pull down their own copy of the repository to do their own work, they would come to this page and they would click on this clone button here, which gives two different URLs, a clone with SSH URL and a clone with HTTPS. If they're a teammate and you're going to expect them to push things to the repository later, what you really want is the SSH URL, because that allows them to both pull and push. So we're going to copy that. And we are going to simulate what it's like for a teammate to check out the repository. We're going to check out another copy. We're going to clone it again. And to do that, we're going to right-click, go to git bash here, and we're going to run the command git space clone space the URL we just copied space the folder that we want it to go in. And we're going to call this just git test2. So we have our original local repository under git test1, and we're making a new clone. We're cloning it again into git test2. So let me hit enter. So that pulled down a new clone. Let me just close this one. If we go look in git test2, we can see all of our files here. So let's make a quick change. I'm just going to edit the main.gd. I right-clicked on it, went to edit with Notepad++, and I'm going to add a comment. I'll say comment from teammate and save that. And close it. And then I'm going to right-click in this git test2 folder and do git bash here. So I have another git command line for this other clone of the repository. Sorry if this is going to get confusing with the two different copies, but I want to show you what it's like when two people are pushing and pulling from the same repository. So if we do git status, we will see that the main.gd has been modified. If we do git diff, we'll see that this comment has been added. So we're going to commit that. We're going to do git commit -a. which will bring up our Notepad++ to type the commit message. We'll just say commit from teammate. Save it, close it. Git has made the commits. We can look in Git log and see this new commit from teammate. And then we're going to do git push. Now this is going to work without us having to have added the remote and done the -u to set the upstream, because by default, when you clone a repository, Git will automatically add the place that you cloned it from as a remote called origin, and it will automatically set the upstream for the default branch, the branch that you cloned down, to be that remote. So we can just straight out of the gate run git push. So this will push that new commit that I just made over to GitLab. If we go here and go to repository commits, we will see this commit from teammate is now pushed to GitLab.com, and here's the diff. So now, if we go not in git test 2, but back to our original git test 1, is that this one? Okay. Now, from the original local copy of the repository, we're going to run git pull, git space pull. And it's pulled down the changes. We can see this fast forward merge. We'll talk a little bit more about the different types of merges when we get to the part on branching and merging. And we can see that one line was added to the main.gd. And if we do git log, we can see now the commit from teammate is here. And if we go over to git test 1 and edit the main.gd, and just edit it with Notepad++, and we'll see that the comment from teammate is there. So that's the basic workflow. Once you have the remote registered and your project is pushed up there, you're going to be making commits and Git pushing them, and then later doing Git pull to pull down the commits that your teammates have made. So let me pause the video and reset these changes so that we can do them again, all of them except for the creation of the SSH key that we did in the beginning. We're going to redo all of them using the Git GUI instead of the Git command line. All right, I have undid the changes we made to our local copy of Git test 1, and I deleted and recreated the Git test 1 project on GitLab.com so we could do the initial push to GitLab using the Git GUI. So like before, we are going to copy this git SSH URL from here. And then I'm going to go over to the Git test 1 folder. I'm going to right click and do Git GUI here. The first thing we need to do is add the remote. So we're going to go to the remote menu at the top and click add. It's going to ask for a name, which is going to be origin, and a location, which is the git SSH URL that we copied. And then under further action, we're going to change it to do nothing else now. So it's just going to add the remote and not do anything else. I'm going to click add. So now we are going to click remote again and go down to push. Here it has the source branches. The only one that's there is master. Select master. I'm going to push it to a remote with the only option selected, origin, and click push. And it was a success. So now again, if we go back over to GitLab.com and refresh this page, we will once again see all of the files from our Git repository here. So the next thing we want to do is clone the repository, again to simulate as if we were another teammate cloning it down. So we're going to click the clone button here, grab the SSH URL, and I'm going to minimize all this stuff. Right click on the desktop here. I'm going to do Git GUI here. And because there isn't a Git repository here, it loads this kind of title screen rather than that dashboard that we're used to. And click clone existing repository. We'll give the source location, which is that URL that we just copied from GitLab.com, and a target directory, so git test2. So again, we're cloning that same remote repository down to a new directory called git test2. And click clone. And it's a success, and we're back in this dashboard. So again, we're going to do that same change to simulate a teammate making a change. We're going to edit the main.gd, going to add a comment from teammate, save it, close it. And if I go over to our Git GUI that's open at git test 2 and click rescan, we'll see there are some changes to the main.gd. We'll click stage change to stage those changes for commit, and then type a commit message. So we'll say change from teammate, and click commit, and then click the push button here. And all of these defaults are fine. The source branch is the master branch. We're pushing to a remote called origin, push. And it's a success again. If we go back over to GitLab and go to repository commits, we will see that change that we just committed, the change from teammate, and click it to get the color-coded diff with the change. So now, if we want to pull that change down into our original copy of the our original local Git repository, we go back into Git GUI for, no, that's just the folder. Where's Git GUI? Yeah, here's Git GUI for the Git test 1. And this is a little bit more complicated. There is no Git pull in the Git GUI. So you have to do it in 2 steps. First, we have to do a Git fetch to pull down the remote commits, and then we have to do a Git merge to merge those commits into our local master branch. So the first part of that, we click remote and go to fetch from and click origin. It fetched the changes. It was a success, so we close that. And then we click on merge and go to local merge. And we're going to use a revision expression. So we leave this checked on revision expression, and we're going to type origin, the name of the remote, slash the name of the branch, master. So we are merging from a branch called origin/master, which is like our own copy of what the origins master branch is, into our local master branch. Click merge. So now we can see it did the fast forward merge, and that one line has been added to the main.gd file. So we'll close this, and we'll go to the git test 1 directory, and we can edit the main.gd and see that the comment from teammate is there. So that is basically how you do that push-pull workflow with the Git GUI. And I think that's all that I wanted to show you today. So let me get back to my presentation. That's all for this part. If there's anything I missed or anything that was unclear or anything that you'd really like to see in future parts, please leave me a comment below or send me a message. In the next part, we're going to be getting to some really exciting stuff. We're going to cover building your project with GitLab CI. And by building, I mean creating game builds. So we can set it up so that every time you push a commit to GitLabcom, that GitLab CI will automatically export your game for Windows, Linux, macOS, HTML5, whatever, and then push that somewhere so that your testers can download it, or you can push it to itch.io or to Steam or whatever. It's super cool stuff. I am really excited to finally get to that part, so I hope to see you next time. Catch you later.